Right, there's my generator. I'm turning it manually. And now what I want to focus here now is what do we get when we have split rings or when we have slip rings. All right, so there you can see those we call the slip rings. It's two solid rings, but if I can just pause it, you can see the one end is attached to that ring, the other, or this one, the other end is attached to that ring. So the circuit is completed. It goes out through to the other ring, and it goes through that part, through back to the other ring. So it's a completed circuit. All right, let us first look at the slip rings, which I have in this case. What do we find here? What is happening to the induced current here in the external circuit? And the voltmeter will show me the kind of current that we are having here. So if I resume, let us look what is happening to the current. Here I've got a positive value, goes down to 0. There I have a negative value. Then I have a positive value, and you can see that is keep on happening. There is my graph of potential difference against time. As time goes on at certain stages of rotation, I've got positive values of induced potential difference, and at certain times there is a negative, which just means it's in the opposite direction. So if I just look now at the induced current here in the external circuit, have a look there. You will see every 180 degrees, the current direction is changing. Now, whenever we have current direction that is changing, that is what we call alternating current, all right? So the current direction is alternating. Then it's in this direction, then it's changing into the opposite direction. So what we find here, when I'm continuously turning this armature, that the induced current that we have here will be alternating current. And that you must remember. They like to ask you this question. What is the reason for alternating current? Is because of the slip rings. All right, these slip rings, they are the reason for this current changing in the external part all the time. All right. If we then go and have a look at what will happen with split rings. When I have split rings, have a look now here at the current direction. We did speak earlier on why there is no current at that stage. It's because of the split in the rings. There's a certain moment when there's no current flowing. So at that point there's no current flowing because the circuit is not complete. Okay, it's a broken circuit. So there's certain moments when the current is 0, and that's when indicated there on the graph. But now let us look, if we use a split ring, what is happening to the induced current here in the external circuit? All right, so let us keep our eye on that little arrow. At the moment it's pointing to the right. As it's turning through 180 degrees, it's still pointing to the right. So can you see in this case, our current that is induced is direct current. And you should know, if I want a direct current generator, that means a generator that is generating direct current, I have to use split rings. Okay? Because what does split rings do? Every 180 degrees, it changes the direction. So where with slip rings, every 180 degrees, I would have had a change. Now with every 180 degrees, it forces this direction to stay the same. Because that end of the armature is at the bottom. When it gets to the top, there will be a change in direction in the armature. But because of the slip rings, there will not be a change of direction in the external circuit. So people, just to make it easy, just remember the following. If I want a DC generator, that means generating direct current for me, I have to use the components which we call split rings, the split ring commutator. But if I use slip rings, then I will have alternating current. So I will have an alternating current generator. For the rest of it, I'm still using Fleming's right-hand dynamo rule. everything remains the same. That is the only difference in components, and that explains the difference. How will the graph look for current against time? Here I've drawn the graph of potential difference against time. The graph for current against time will have exactly the same shape, maybe not the same values. In other words, it might be lower, but the basic shape will be also a sine curve, and it will look the same. Just be careful. It might be in the exam that the graph which I give you might start here and first go up and then go down, in the opposite as what we've got here. Then your current graph will also first go up and then come down. So just be careful of that. That's sometimes out of habit. You might lose marks because you're making a little mistake. The question will be, here is a corresponding potential difference against time graph. How will the corresponding current against time graph look? It will have the same basic shape. All right, so you just draw a sine curve there. All right, but if the sine curve is in the opposite way around, then you just draw the current graph also in that very same direction. Just be careful of that. All right, guys and girls, I hope that this helps you to understand all the things you need to know about generators and electrical motors. Now we are going to proceed and specifically look at this alternating current generator, because the alternating current generator is very important to us, because that is the current we are receiving in our homes. So all the electrical apparatuses in your home, they work with alternating current, and we need to know a little bit more about alternating current. One of the devices in your homes that doesn't work with alternating current would be a normal cell light, a torch that you can use. The torch will work with direct current, where you have cells that you put in at the back, and you've got a direct current, simple circuit there. But the other apparatus in your homes, 220 volt, it is alternating current. So if you think about 220 volt, there's something here that you need to see, and that is that the potential difference doesn't have a constant value. The potential difference have some moments in this turning process, it have maximum values, and at certain moments it have a value of 0. When the potential difference is 0, which is there, and also now the current induced will be 0. And the reason for that would be that these three things in the dynamo rule, then you will find that at that moment two of them are parallel. So then the third one will be a 0. So whenever there's two of them parallel, you won't have the third one that's been induced, which in this case is current. So on that moment where I have that scenario, my potential difference which is induced is 0, my current is 0. So at certain moments I've got maximums and minimums. Now